Welcome back to another exciting edition of some Algebra 2. Today, we are going to begin talking about Chapter 5, dealing with quadratics, and today we're going to focus on graphing quadratics. Before we talk about graphing them, though, most of you guys probably will recognize this, but may not necessarily be able to put into words what a quadratic function is. A quadratic function is a function with the form y equals ax squared plus bx plus c, where a, b, and c are just going to be the coefficients. If you look at bx plus c, that's the equation of a line. The difference between a line and a quadratic is that x squared term. It's going to do some different things with our graphs. A parabola, we're going to talk about parabolas as well. A parabola is the U-shaped graph of a quadratic function. So unlike lines, these are going to be U-shaped. They're not going to be a straight line. They are, as mentioned, going to look like a U. A vertex. The vertex is very important with quadratics. They help us quite a bit with different things. The vertex is the highest or lowest point on the graph. We'll talk about more about the vertex of a parabola here in a little bit, but it doesn't necessarily have to be the highest. It doesn't necessarily have to be the lowest. It has to be one or the other. The last thing that is very important is the axis of symmetry, which I abbreviate as AOS. Most people that I've seen don't do this, but it's just something that helps, that just shortens up some of the writing that you have to do so that you can make things clear. The axis of symmetry is the vertical line through the vertex about which the graph is symmetric. So, you guys remember thinking back to maybe elementary school or middle school. If something is symmetric, it's the same on both sides. The nice thing about these U-shaped parabolas, they're going to be the same on both sides. So we can use some of that property to help us make graphing a little easier. We talked about another symmetric function, the absolute value function, in Chapter 2, I believe. So these are a little different, but a lot the same. So, here's an example of some parabolas here. Different colors are different parabolas. So, there we go. Let's just talk about this parabola right here. Here's y equals x squared. This is one parabola. As you can see, it's a U-shaped. This is what we say opens up. So it's a smile, because if you have a smiley face, It opens up. Hooray. Then, and I think it's already labeled here, this low point right here, this is our vertex. One thing about these, when we graph these are rounded. They are not pointed like an absolute value graph. They're not a V shape. They're going to be a U shape, so they come to a round. But that low point right there is still what we call the vertex. Now, if we look at the red, this is what we call opens down. Like a frown. And the line that runs right through that vertex right here, and I usually show it as a dotted line. This right here is that axis of symmetry that I'm talking about. If you were to fold either one of these parabolas in half, you would fold it right over into each other and it would match. So that's just something for you guys to be aware of. I'll show you how we can find that axis of symmetry and use it to help us graph here in a second. So, some things that you need to know about quadratic functions. Obviously, we're starting with the form ax squared plus bx plus c is a parabola that we're going to talk about. If a is greater than 0, it's going to open up. So it will be like this blue parabola here. So this a here is going to be a 1, so it's 1x squared. 1 is greater than 0. It's going to open up. If a is less than 0, it's going to open down. And as you can see from here, negative x or negative 1x, negative 1 is less than 0, so it's going to open down, just like we talked about. If the absolute value of a is less than 1, so fraction really is what we're talking about. It is going to be narrower. If, and what I mean by fraction, I'm talking like 1/2. If it is greater than 1, you can still have fractions, but it's going to be greater than 1. So it's going to be your improper fractions, or, you know, like a 2 or 3/2. If that absolute value, again, remember absolute turns everything positive. So if that's greater than 1, it's going to be wider or narrower. The key thing that you want to remember from this particular section right here. Here's a formula that I would write down and remember for forever. X coordinate of the vertex is negative b divided by 2a. It's very important. That's how you find the x coordinate of that vertex. Remember, it is going to be a point, so you need an x and a y. But once you have the x, you can find the y. Which, luckily enough for us, axis of symmetry is the vertical line. X is equal to negative b over 2a. So if I ask you for the vertex and the axis of symmetry, once you have that x coordinate of the vertex, you can write your axis of symmetry. One thing to remember is this x equals, when I ask for the axis of symmetry, it is a line treated as so. So how are we going to do this? Well, we need to graph the function y equals 2x squared minus 8x plus 6. One thing that I like to do is I like to identify my a, b, and c right away. So a is always in front of x squared. that's going to end up being our 2. Our b is going to be negative 8, just like we did before. Since that's negative, that will carry over into our coefficient b, and c is going to be 6. C is always by itself, b is always in front of the x. To find our axis of symmetry, you're going to use x equals negative b over 2a. So you're going to take negative 8 divided by 2 times 2, which, because we have double negatives here, we can make those both positive, and we get 8 over 4, or x equals 2. That is a vertical line at x equals 2, so there's x equals 2 right there. And like I said, I like to put a dotted line in it. Just something to help me find that. Now, because I know that x equals 2, my vertex is going to sit right on that axis of symmetry. To find the y value for that, I am going to plug in x equals 2 into my equation here. So I'm going to get y equals 2 times 2 squared minus 8 times 2 plus 6. Okay, remember your order of operations here. We have to take care of those exponents before we take care of anything else. So you're going to get y is equal to 2 times 4 minus 8 times 2 plus 6. I like to wait on any of my multiplication. You don't have to. You can multiply the 8 and the 2 whenever you want. I just like to do all the multiplication in one step. So you're going to get 8 minus 16 plus 6. 8 minus 16 is negative 8 plus 6, so y is going to be negative 2. So your vertex is going to be at 2, negative 2. Okay, great. We've got our vertex. Now we just need some more points. Whether you guys remember or not, I told you there's always one sure way to get points. Well, you make yourself an XY chart. With these, I want to graph these. I want 3 points, one of which is your vertex. So we need to get 2 more because we already have our vertex. So let's pick x to be 0. Why would I pick x to be 0? Well, when I plug it in, I get 2 times 0 squared, which ends up being 0, minus 8 times 0, plus 6 goes away. I'm left with 6. So I plot the point 0, 6. Right there. And now here's where our symmetry helps us. Since I have two units on our graph to the left of the axis of symmetry, I'm going to go 2 units to the right, and I have another point that is the same y value, and I can draw my parabola. I have my 3 points. I've got one on each side of the axis of symmetry, and I have my vertex. So draw your line here and there, and try to hit your points a little better than I did on the right there. And remember, this is not a point down at the vertex, so try and make that curved. I know this one is skinnier, so it's going to look more pointed, but it is not going to, it's actually a curve. Okay. So if you want to take a break here, I know this video is getting long. This will probably be one of the longer videos that we do. Take a break, stretch out, whatever. If you want to try some of your homework problems, definitely you can do that. You guys know how that works. So go ahead, pause if you want right now. Otherwise, I'm going to keep moving on. And I'm going to talk about vertex and intercept forms of a quadratic. Before, we were dealing with what's called standard form. But today, or not today, but well, now we're going to talk about vertex form and intercept form. Vertex form. The reason they call it vertex form is because we can identify the vertex. So you're going to look at this h, which goes with the x, plus k. That is going to be your vertex, is at the point hk. One thing to be careful of, check your signs. So x minus h, okay, so it looks like minus, but it comes out positive. So inside your parentheses, it's going to be opposite of what it seems outside. The k is positive here, and it's positive in our point. One thing to make sure that you watch there. And when we talk about intercept form, then again, watch your signs. And if we have x minus p times x minus q, then the x-intercepts, or where we cross the x-axis, are at p and q. Again, make sure that you get those correct on those signs. If you see the subtraction signs, they're going to be positive. If you see addition signs, they're going to be negative. And if you are looking for your axis of symmetry, it's going to be halfway in between those points. Again, the A out here is just to help you determine whether it opens up or opens down and whether it's going to be wider or skinnier. We've got an example here. First of all, when you look at these problems, you need to determine what form you're working with. So, since I only have one set of parentheses and it's squared, this is going to be vertex form. Which means that our vertex is at the point. Well, I see a positive, which means I'm dealing with a negative 3. That is my x value. X's go together. And I have a positive 4 that is outside the parentheses. So since it's outside, I take it at face value. So my vertex is at the point negative 3, 4, which means that my axis of symmetry is at x equals negative 3. So I can put that in right here. And I go negative 3, 4, and I've got my vertex right there. One thing I like to do right away, after I kind of get my vertex and my axis of symmetry, I look there. I'm going to say that this opens down because it is negative. Now, I just need to get some more points. Again, to get some more points, pick different x values. We're going to make our xy chart. I'll change colors so you guys can see these points a little better against my blue. So, I'm going to pick an x value of negative 1. Why negative 1? Because I know how this is going to happen, how things are going to work out. And really, it's because I have this 1/2 here. I know I'm going to end up with an even number if I plug in negative 1. So I get y equals negative 1/2 times negative 1 plus 3 squared plus 4. And now it is all order of operations. So you get negative 1/2 times negative 1 plus 3 is 2 squared plus 4. And here's why I chose the negative 1/2 times 4. 4 multiplies 1/2 very nicely. You can cut it into 1/2. If you picked -2, you would have gotten fractions, and I know how much you guys like to work with fractions. Negative 1/2 times 4 is going to give me -2 plus 4, so y is going to be +2. So I've got the point -1, 2 right there. Again, use symmetry to reflect that over. I'm 2 to the right now, so I got 2 spots there. So I've got to go 2 spots here, and I open down, and there I go. So that's all there is to that one. The next one we're going to take a look at. Graph y equals negative x plus 2 times x minus 4. Okay? Well, I have to identify what form. This is intercept form. So that tells me that my intercepts are at, well, my x value, I see a positive, again, in parentheses. That means I'm dealing with a negative. So I have -2, 0, and I see a -4 here, which means I'm dealing with a +4, 0. So plot those points. -2, 0, 1, 2, 3, 4, 0. And look at that, I've already got 2 points on my graph. Now, to find my axis of symmetry, to find the point halfway in between these two, all we do is we find the average of them. So I'm going to take -2 plus 4 divided by 2. So since I'm adding 2 numbers, I divide by 2. So I get 2 over 2, or x equals 1. So I put my axis of symmetry right here at x equals 1, vertical line, and now I just need to find where my vertex is, and I can plug into my formula. Y equals -1 plus 2 times 1 minus 4. Again, take care of your parentheses first. -3 times -3, and I get -3 times -3 is going to give me a -9. And again, my double negative means I've got a positive. So when x is 1, y is going to be 9. I go all the way up here to 9, put my point. I've got my 3. It opens down, which I could identify right away from that negative. And I do my best to hit these points. There we go. And that's our graph for that. The last thing we want to talk about, writing the function in standard form. That is what I told you earlier was y equals ax squared plus bx plus c. Okay? We're going to use a method called FOIL, and I didn't want to write that there. So FOIL stands for first, outside, or outer, inner, or in, inside, whatever. L stands for last. Hopefully you guys have done this from Algebra 1. So what that means is I'm going to multiply, and this is going to get a little uglier than what I want. So x times x, those are my first terms in each set of parentheses. outside, so I'm going to take the two most outside. Outside terms, x times -9, so I'm going to get -9x. Inside or inner, 4 times x. I have a positive 4 times a positive x. The reason I got -9x was because I had a positive x times a -9. So I'm going to get 4x. And last, I'm going to get positive 4 times a -9. That is going to be minus 36. So you're going to get negative x squared minus -9x plus 4x. You're going to get negative 5x minus 36. And we just use our distributive property to distribute this negative to everything after that. So you get y is equal to negative x squared plus 5x plus 36. Then for part B, same idea. The only difference is how we're going to handle this x minus 1 squared. So you're going to get 3 times x minus 1, and squared means I'm multiplying it by itself, x minus 1 plus 8, not 1. I'm going to FOIL this real quick for you, just to cut down the time on this video. So you're going to get 3 times x squared minus 2x plus 1 plus 8. And we're going to distribute our 3 to everything. Inside our parentheses, you're going to get 3x squared minus 6x plus 3 plus 8. And now I collect my like terms, which happen to be my 3 and my 8. And I'm going to get y equals 3x squared minus 6x plus 11. And there it is in standard form. Okay, we'll have lots of time to work on this. I apologize for the length of this video. Hopefully there are none others that are this long. But we'll have a couple days in class to work on this. A lot of time for you guys to work. So let me know if you have questions, and I'll see you guys next time.